Hey guys, Mr. B here again, bringing another math video. This one on one thing we're doing, I'm actually doing in class right now with my students, is using the chain rule and taking the derivative of an inverse trig function. So the first of all, an inverse trig function is something like this. Y is equal to sine negative 1 of x. So that guy right there is an inverse trig function. Now oftentimes you'll see it in calculus written as arc sine of x. So I guess one of the reasons is they don't want to confuse this inverse with reciprocal, because sometimes you have exponents of negative 1, they mean reciprocal, as opposed to this one, which means inverse. So first of all, the thing we need to remember is that the derivative of these things is just, you kind of know them. There are proofs for them. A lot of times some teachers might require you to know it or not, but for the most part, the majority of where your questions are going to come from is just knowing the proofs of these derivative. So it's really important to know, like for example, that the derivative of arc sine, well, I'll write arc sine of x, so the derivative of it is 1 over square root of 1 minus x squared. So that's the derivative of them. So you just need to know those. So if you're still having trouble with them, I'll write a few of them out here. So I'll write the main four. So then the derivative of, I don't know why I'm using capitals, but I am, arc cos of x, y prime, it's just negative 1 minus x squared, just like that. Now the derivative of arc tan of x is y prime is equal to 1 over 1 plus x squared. The derivative of arc cotan of x is y prime negative 1 over 1 plus x squared. So there's the four main derivatives that you guys need to know. Now the thing about them is you really just need to know them. So my suggestion is you put those in the memory bank and make sure you remember remember them, and that way it's just like a tool in your toolbox. So I'm going to use them to find a few more, to find a couple of examples, and then that way we can use them for some other things. Now I will put the other two here that are missing, just in case you need to know them. So I don't know if I got space over here, but I'll try and fit it in. So the derivative, actually I'll write it down here, the derivative of arc secant x y prime is equal to 1 over the absolute value of x square root x squared minus 1. And then I got space for one more here, which would be arc cosecant of x y prime is equal to negative 1 the absolute value of x square root x squared minus 1. So you got to memorize all 6 of these guys. Alright, so let's put it in action. I'm just going to rip this page off and give you guys an example now of, inverse trig with the chain rule is what I'm going to do this with, specifically with the chain rule. Alright, so let's try this guy. So y is equal to arc sine of 3x. So it's a fairly simple derivative. So what you need to remember is that the derivative of arc sine is 1 over square root 1 minus x squared. Now my students sometimes like to think of it like this. 1 over square root 1 minus u squared times u prime. So this is what I call the chain rule form, which really is the most useful form, because you're not really going to get these just what is that, like that's never going to happen. You're always going to have something inside of this guy, so this is definitely the most useful form to remember. So essentially what I have is my u is 3x. So what's inside the arc sine function? So when I take the derivative of this, I get y prime is equal to 1 over 1 minus u squared, so that becomes 3x squared, times the derivative of u. So the derivative of u is just 3 times 3. So this reduces down to 3 over 1 minus 9x squared. Just like that. So I mean, that's not too shabby, right? Like, I mean, it's a fairly straightforward question. If you know this form, it's fairly easy to get away with it. like know it. You just need to know it. You need to just know it. Let's try another example here. Let's try something a little more complicated on the inside. So let's go with cos this time. Arc cos. And let's put a quadratic on the inside. So let's go with x squared minus 1. So this time I have something in here. So my u this time is x squared minus 1. So then I go ahead and use my form right here. So 1 over square root. Now it's negative for cos, of course. So you got to remember that this is for arc sine. Negative for cos. So 1 minus x squared minus 1 squared times derivative of this guy. So derivative of u is 2x times 2x. So negative 2x. All divided by 1 minus x squared minus 1 squared. So again, depending on your teacher or the format of your test, you might have to work this out. So again, I will write this here just in case anybody's has a question like this. You need to remember that x squared minus 1 times x squared minus 1 looks like this. So I'm not going to do that because I don't really consider that to be simplifying anything. Expanding that it doesn't serve any purpose to me. So I'm just going to leave it alone. All right, let's try an even harder example with something more complicated inside. So let's try this guy. So let's go arctan this time, and let's say square root of 6x. So let's throw a root in there just to make it a little more complicated. So in reality, this is a chain rule question with a chain rule question inside. So my u this time is square root of 6x. So the thing about it is to take the derivative of this, I have to use the chain rule again because there's something inside of this function that's not just x. So let's start it anyway. So I'll write the form up here. So 1 over 1 plus u squared. So remember our derivative is just 1 of arctan. It's just 1 over 1 plus x squared. So when there's something inside of arctan, it's a 1 over u squared, and then we tack the u prime on the end. So it looks like this. So 1 over 1 plus my u is root 6x squared times the derivative of root 6x. So I still need to do the derivative of that guy. So now what I want to do is, I can simplify this by canceling out the root. Now this guy over here I need to take the derivative of. So again, this is just chain rule. So my u is 6x. So what I have is 1 over 2 6x to the negative 1 over 2 times 6. So I'll just tack that in there and I'll just explain where that comes from. So remember, we can write anything with an exponent to the half. So the derivative of this guy is 1 over 2 x to the minus 1 over 2. So the derivative of any root, so if it's 1 over u squared, it's just going to be 1 over 2 u to the negative 1/2 times u prime. So that right there, that 6 is my u prime. And so I just basically filled in, where that u would go right there. So that u goes right there. That's the u. That 6 is my u. And if you can see the prime there, it's right there. Let me just see if I can't squish this in a bit. I can't move it in any further. Oh, there it is. There you go. All right, so now I just need to simplify. So I'll cancel this root, change this to a 3. So I get, I'll put that 3 all the way over on top of this guy. Times 6x to the minus half. Again, all depends on what your teacher wants you to do with this, guys. I'm just going to take it to the bottom and change it to a root. And there it is. That's as far as I'm going to take it. And you know what? If you're on a test, I probably would have gave you full marks for this guy right here. Alright, guys. So hopefully that sort of sheds a little bit of light on how you take the chain rule and some inverse trigonometric functions. There, of course, these quickly escalate in difficulty depending on what's underneath, so, or what's inside, I should say. So the harder this is, the harder it is the overall question. So make sure you practice some of the harder ones. And thanks for watching, guys. I'll see you guys in class.